Welcome once again to Bio 211D, Plant Physiology, Unit 6, Session 4, Factors that Affect Transpiration, Abiotic. And at the end of this session, you should be able to state environmental factors that affect transpiration rate, explain how some environmental factors affect transpiration rate, compare the effect of environmental factors on transpiration, and compare the effect of plant and environmental factors on transpiration. Lights. It influences stomata opening. Stomata are triggered to open in light so that carbon dioxide is made available for the process of photosynthesis. Stomata are closed in the dark in most plants. However, very low levels of light at dawn can cause stomata to open so they can access carbon dioxide for photosynthesis as soon as the sun shines on their leaves. Light levels as low as 1,000 of the sun can cause stomata to open. Stomata are most sensitive to blue light, the light predominating at sunrise and one of the wavelengths of light most effective in photosynthesis. Since stomata open in light, plants transpire more rapidly when light is available than in the dark. That is because light largely stimulates the opening of the stomata. Transpiration is more rapid in light. Light also speeds up transpiration by warming the leaf, since this will increase the magnitude of the driving force of water out of the leaf. Temperature. It greatly influences the magnitude of the driving force for water movement out of a plant rather than having a direct effect on stomata. Warmer air holds more water, thereby creating a larger driving force for water movement out of the plant and increasing transpiration. That is, the water potential of warm or hot air is much lower than in the intercellular spaces in the leaf. This creates a water potential gradient in favor of water loss or movement of water out of the leaf. As temperature increases, the water holding capacity of the air surrounding the leaf or plant increases sharply. The amount of water does not change, just the ability of the air to hold water. Since warmer air can hold more water, its relative humidity is less than the same air sample at a lower temperature or its drier air. Cooler air, on the other hand, holds less water, hence its relative humidity increases or it is moister or moister air. Therefore, warmer air will increase the driving force for transpiration, whereas cooler air will decrease the driving force for transpiration. As such, plants transpire more rapidly at higher temperatures because water evaporates more rapidly as the temperature rises. At 30 degrees Celsius, a leaf may transpire 3 times as fast as it does at 20 degrees Celsius. That is, for just an increase in temperature of just 10 degrees Celsius or 50% rise in temperature, transpiration rates increase by 100%. Relative humidity is the amount of water vapor in the air compared to the amount of water vapor that the air could hold at a given temperature. A hydrated leaf would have a relative humidity near 100%, just as the atmosphere on a rainy day would have. Any reduction in water in the atmosphere creates a gradient for water to move from the leaf to the atmosphere. The lower the relative humidity, the less moist the atmosphere, and thus the greater the driving force for transpiration. So when relative humidity is high, the atmosphere contains more moisture, reducing the driving force for transpiration. The rate of diffusion of any substance increases as the difference in concentration of the substances between any two regions increases. When the surrounding air is dry, diffusion of water out of the leaf occurs more rapidly, and as a result, transpiration also increases. The wind can alter rates of transpiration by removing the boundary layer. Remember that the still layer of water vapor surround the surface of leaves is the boundary layer. Windier conditions increases transpiration because the boundary layer is reduced, as discussed in the previous session. Wind increases the movement of water from the leaf surface when it reduces the boundary layer, since the path for water to reach the atmosphere is made shorter. So when there is no breeze, the air surrounding a leaf becomes increasingly humid, reducing the rate of transpiration. When a breeze is present, the humid air is carried away and replaced by drier air. The drier air creates a water potential gradient, thus causing transpiration of water from the leaf to the atmosphere. Oscillating and wall-mount fans can be used to replicate this indoors. Growing media. Remember that the source of water for transpiration out of the plant comes from the soil. Plants with adequate soil moisture will normally transpire at high rates since the soil provides the water to move through the plant. Plants cannot continue to transpire without wilting if the soil is very dry, because the water in the xylem that moves out through the leaves is not being replaced by the soil water. This condition causes the leaf to lose turgor or firmness and the stomata to close. If this loss of turgor continues throughout the plant will wilt, since there will be inadequate water to replace that loss to the atmosphere. Therefore, a plant cannot continue to transpire rapidly if its water loss is not made up by replacement from the soil or whatever growing media. When absorption of water by the roots fails to keep up with the rate of transpiration, loss of turgor pressure occurs and the stomata closes. This immediately reduces the rate of transpiration as well as of photosynthesis. If the loss of turgor extends to the rest of the leaf and stem, the plant wilts. The volume of water lost in transpiration can be very high. It has been estimated that over the growing season, 1 acre of maize plants may transpire 400,000 gallons, which is equivalent to 1.5 million liters of water. As liquid water, this amount would cover the field with a lake 38 centimeters deep. You can then imagine about water an acre of forest would lose in a year. So, in review, the environmental factors that affect transpiration have been outlined and thoroughly discussed in this session. Thank you for your audience and time once again.